Okay, now that we have the skills, we're going to apply them in certain situations. So our first question is, the roots for two quadratic functions are given. Write the equation of each function in factored form if the a value equals -5. Okay, so if a root is -2 and another root is 3, that means that the parabola is crossing the x-axis at those places. So x would equal -2 and x would equal 3. But when I write this in factored form, I want to have factors that would equal 0. So in order for this equation to equal 0, I'm going to add 2 to both sides. And I have x plus 2 equals 0. And then for x equals 3, in order for that to be a factor set equal to 0, I have to subtract 3 from both sides. X minus 3 equals 0. Okay, now that I have my two factors, and I know my a value is -5, I can write my equation as y equals -5 times x plus 2 times x minus 3. That is in factored form. Now that you understand how we got from our two roots to our final factored form, this is the only thing in the future that you need to write. As long as you understand how we ended up going from the values of the roots to our final factored form, you do not have to show this information. So looking at B, if my two roots are -6 and -1, that tells me the parabola will cross the x-axis at those two places at -6 and -1. If my a value is -5, my equation in factored form is y equals -5, parentheses x plus 6, remember the opposite of what the root is, times x plus 1. Okay, looking at number 2, write the equation for the function of the graph given below in factored form. A equals 1. Okay, so think to yourself what other information you need for factored form. And you're right, you would need the roots or the zeros of the graph. So I look carefully at the graph and I realize, well, one place the parabola intersects there is at -4. And the other place it intersects the x-axis is at 3. So given those two zeros and the fact that a equals 1, I'm going to pause and you write the equation in factored form. Okay, let's see if you agree with this. We're going to write it y equals what my a value is was 1. And if this is a 0 in factored form, I'm going to write the opposite of that integer, x plus 4. And I'm going to write the opposite of that, x minus 3. And what you could do is put that in the y equals of your calculator, press graph, and make sure that it matches that graph. Okay, moving on, now you're asked to write the equation for each function in vertex form, given a in the vertex. So remember that the general form of our vertex form is y equals a times x minus h squared plus k, where hk is our vertex, the opposite of what's in the parentheses, and then we copy exactly what that k value is. So I want you to pause for A and write down what you think the equation would be. Okay, now we're back. Let's see if you were correct. This would be y equals, my A value is 1, parentheses, I'm going to write the opposite of this x value, so x plus 2, squared, remember this has to be squared in vertex form, and I'm going to copy that y value exactly, -7. Okay, let's look at B and do the same thing. You're going to pause and write the equation in vertex form and then check with me. Okay, and we're back. Let's take a look. We have y equals, the a value is -2, parentheses. We're going to take the opposite of that value, so x minus 4, the quantity squared, and we're going to write the y value here. But if I write plus 0, that's the same thing as not writing a number at all, so this is written in the simplest form. Okay, moving on to number 4. Sometimes it's given to you in vertex form, and you need to just write the vertex. So you just make sure it's in this form that we spoke about here. And looking at this, pause the video and write the vertex for A and B. All right, and we're back. So the vertex for this would be the opposite of what's in the parentheses, so a +7, and we copy exactly what's outside here, -4. All right, looking at B, we're going to write the opposite of what's in the parentheses, a -4, and we're going to copy what's outside the parentheses, a +6. And that is the vertex of each of the parabolas. Now you could be asked a little bit different. Write this equation in vertex form of the function shown in the graph below if a equals 1. We wouldn't be able to write it in factored form because this parabola never touched the x-axis, but we could write it in vertex form. So think about what you need first to write it in vertex form. That's right, you need the vertex. So I take a look at the turning point here. My turning point there, +2, and 1 is your y coordinate. So if a equals 1, and my vertex is 2, 1, think about what that would be in vertex form. Pause the video, write your equation, and then check with me. And we're back. And in vertex form, it would be y equals my a value 1, parentheses, I'm going to write the opposite of that, x minus 2, remember this has to be squared, and I'm going to copy that exactly +1. All right, this is one of my favorite questions, and I really would have loved to have taught this in the classroom where you could have had a great discussion in your group. But you can still have some great thinking going on with this. Here is a parabola. Notice we don't have any numbers written here, but there are some information that you could get just from seeing how this is graphed. And on the side here are different quadratic functions written in forms. Some of them are factored forms, some of them are standard forms, or vertex form. Think about what each of the form is telling you about the graph. Your job is to select every equation here that could possibly apply to this graph. So please pause and think about this. Be able to defend why you picked the certain equations or why you could tell me ones did not work. All right, so take the moment to pause, work on all of them, and then we'll come back. Okay, we're back. Let's see how you did. So looking at A, I recognize this is in factored form. And when it's in factored form, I can easily see the roots. So I know the roots are the opposite of what I see in the parentheses. So the roots are a -2 and a +5. I also know, since this is a positive outside here, that this is going to be a parabola that opens up. So first, it does look like a parabola that opens up, but looking at the roots here, both of these had to be positive numbers. If this was a -2, the parabola would have been over on this side, crossing the x-axis. So this does not work because the roots on both of this graph are positive. Going to B, I recognize that this is in standard form. And standard form tells me two things. It tells me how the graph turns. So this graph is turning down, turns down. And it also is telling me that this graph is touching the y-axis at -1. The y-intercept is -1. So you could have rejected this equation for this graph based on either one of these. This graph does not turn down, it turns up. The arrows are pointing up. And if this keeps on going, eventually this will cross the y-axis, but it will cross it at a positive value, not at -1. So for those reasons, B is crossed out. Looking at C, this tells us the graph turns up. Because it's a positive value, it turns up. And the roots are the opposite of what's in these symbols. So the opposite of -6 is a +6. The opposite of -10 is a +10. Both roots are positive, and both roots are positive here. So this is a possibility. We don't know for sure because we don't have the exact numbers, but this is definitely a possibility. All right, looking at D, we notice this is in vertex form, and this is telling us two things. This is positive here, which tells us the graph turns up, which we say, okay, that can work. Also in vertex form, the vertex is going to be the opposite of this, which is a -5. And we copy exactly what's outside here, 4. So we're saying the vertex is -5, 4. Looking at the vertex here, the x value would have to be positive and the y value would have to be negative. So positive x value, negative y value. That does not work in here. That's actually the opposite. So D is not a contender. Now taking a look at this last one, this is in vertex form. Since this is positive, I know that the parabola is going to turn up. And the vertex, I look at the x value, it's going to be the opposite of what's in the parentheses. So the vertex is going to be a +8. And we copy exactly what's outside there, a -6 for the y value. A positive x value, a negative y value. And that matches what I see in this graph. So this is also a contender. So if you got that all right, congratulations. If you didn't, please just make sure you understand where you made your error. Okay, looking at something else to think about. Any equation written in this form, y equals a parentheses x squared plus x minus 12, where a is a constant, doesn't matter what a is, will have the same solution set as this equation. For example, please graph these equations on your calculator. So you're going to go to y equals and you're going to put both of them into your calculator. Then I want you to look at the graphs. What do you notice? So pause the video to do that. And when you're ready with some ideas, what do you notice that might be the same? What do you notice is different? Come back to this. Okay, so hopefully you notice some interesting things. Let's compare and contrast. So compare is what do they have in common? Contrast is what do they have that's different? Well, we already were told that they are going to have the same solution set. So if you did look at the table of values to make sure, you noticed they did have the same solution set. But there was something else that was interesting when you looked at the graph. They both crossed the x-axis in the same places, which means we can say they have the same zeros, the same roots. However, you were able to see that there were two different parabolas. And the reason why you were able to see it is one parabola was more narrow than the other parabola. In a few lessons, we'll be discussing why that happens and how you could have known it from the equation. But for now, just understand that because you were able to graph it on your calculator, you were able to see that exactly. Okay, so for our takeaway, we're going to summarize what we had done. So I want you to think about the three forms that we had studied and what those general forms look like. Please pause the video, write that in, and then you're going to check to see if you got that correct. Okay, and we're back. Let's see how you did. So one form was standard form. Y equals ax squared, because we're going to write the variable with the highest degree first, plus bx plus c. Another form was factored form, where we could easily see the roots or the zeros quickly. That was y equals a times x minus r sub 1, the first root, times x minus r sub 2, the second root. And the last form was the vertex form. And that one, we can easily see the vertex. So y equals a times parentheses x minus h parentheses squared plus k. Okay, great job. And looking forward to talking with you at Zoom. Take care.